you will understand that in the half of the reaction we know that oxidation will be taking place. In another half we know that the reduction will be taking place. In both the sides we need to add the electrons. Why it is reduction? Because the oxidation number is decreases from +6 to +3. While balancing the oxygen, we need to add the OH minus ion on the right hand side of the reaction. Hello my dear students, a warm welcome you all. Myself is Purnima, lecturer in Department of Chemistry at Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. My dear students, in our last discussion, we were dealing with the unit called Redox reaction. Under that, we talk about the balancing of redox reaction by oxidation number method. Today, let us move on to the next topic of this unit by balancing the redox reaction by using half reaction method, which is also known as ion-electron method, and application of redox reaction we are going to discuss in this session. So firstly, we will see what is ion-electron method. By using this, how to balance the redox reaction, let us understand first. This is also known as half reaction method. The method of balancing the redox reaction by ion-electron method was developed by Gittel and Gemev in 1927, and they have put forward some of the steps here. In the first step, we will write the skeleton of that equation by assigning the oxidation number to the each reactant and the product which are involved in a chemical reaction. And in the second step, we are going to separate the half reaction where the oxidation and the reduction will be taking place. So in the second step, split the redox reaction into the half reaction, one for the oxidation, one for the reduction. Okay, and balance the atom rather than the hydrogen and oxygen in each half reaction and multiply with the suitable integer. So remember, in the first step itself, we will write the skeleton of that equation, and also we are finding out the oxidation number of the each reactant and the product which are involved in that reaction. Whereas in the second step, we just separated out the half of the reaction like oxidation and the reduction, and we will balance the equation in such a way that we should multiply with a suitable integer except oxygen and hydrogen. And remove the electron from the oxidation half reaction and add the electron to the reduction reaction. Next, in the third step, multiply the oxidation equation by added electron, reduction of a half reduction, and the reduction equation by removed electron of a oxidation of half reaction, so that number of electrons are become equal on the both the side. You will understand that in the half of the reaction we know that oxidation will be taking place. In another half we know that the reduction will be taking place. In both the sides we need to add the electron. That is why this method is known as ion-electron method. So we need to add the electron in such a way that how much the electron will be get lost. We need to see that, and we need to add the electron, and that the electrons in both the steps must be balanced. And in the fourth step, balance the hydrogen and oxygen atom by water molecule by using hit and trial method. Again, there are of two different medium will be there, acidic medium as well as in the basic medium. Already you have understood that how to do with the acidic and the basic medium in the oxidation number. Same thing will be followed here. We'll see with an example so that we can easily solve the numerical, because this is very important to balance the redox reaction from this chapter. They can ask oxidation number method or the ion electron method. That is why both the method you must learn properly. So first I'll go with an example. Balance the following redox reaction by half reaction method. Half reaction method in the sense, you need to understand that this is ion electron method. Ion electron method. So what is the given equation here? Fe2 plus Cr2O7 2 minus give rise to Fe3 plus Cr3 plus. So this is in acidic medium. What is the first step? The first step is you need to write the skeleton of equation and you need to find out the oxidation number of the each reactant in the product which are involved in that reaction. So first I'll write the reaction Fe2 plus Cr2O7 2 minus give rise to Fe3 plus Cr3 plus. Is it right? Yes. We know that we need to balance the equation in the first step itself. How to balance this? By finding out the oxidation number. We know that for the Cr2O7 2 minus, how to calculate the oxidation number? I'll consider this as X. So 2 into X plus 7 into minus 2 is equal to minus 2. So 2x minus 14 is equal to minus 2. So 2x is equal to 12 and x is equal to plus 6. Is it right? Plus 6 is the oxidation state of the Cr2O7 2 minus. During the reaction, it gave us to the Cr3 plus. So that the oxidation number will get changes from plus 6 state to the plus 3 state, so that it will be decreases. So it is reduction. Why it is reduction? Because the oxidation number is decreases from plus 6 to plus 3. Similarly, you can see that iron, which is exhibits in the plus 2 oxidation state, during the chemical reaction it gains to the plus 3 oxidation state. So that oxidation number which has been increases from plus 2 to plus 3. So it is oxidation. This is the first step. We need to identify the oxidation number of the reactant and the product which are involved in the chemical reaction. And in the third step, we will separate it out into half of the reaction by writing oxidation in the half reaction. That is, iron will give rise to the iron 3 plus, where the plus 2 state of the iron will be increases to plus 3. Since it increases the oxidation number, hence it is an oxidation. Whereas on the another hand, Cr2O7 2 minus, which gives rise to the Cr3 plus, you can see that the oxidation state of this Cr2 is plus 6 and it will be decreases to plus 3. So it is reduction because the oxidation number will be reduced. This is the second step. In the third step, balance the atom other than the oxygen and hydrogen in the each half reaction individually. Here, oxidation of the half of the reaction is already balanced with respect to the iron atom. For the reduction of the half of the reaction, we need to multiply with the 2 to balance the chromium atom. How? Because we know that there are only one iron atom will be there. So, no need of balancing this oxidation half reaction. Whereas in the reduction, we know that there are Cr2 will be there. There are 2 chromium atom will be there. So, we need to multiply with the 2. That is why I have written Cr2O7 2 minus 2 Cr3 plus. This is a third step where you need to balance the half of the oxidation and reduction reaction by multiplying with a suitable integer. Then in the fourth step, for the reaction occurring in acidic medium, add the water to balance the oxygen atom and H plus to balance the hydrogen atom. So we get Fe2 plus Cr2O7 2 minus, which gives us the Fe3 plus 3 Cr3 plus. We know that here there are 7 oxygen atom will be there. So I will write 7 oxygen. If I write the 7 oxygen by taking the water molecule, it becomes 14 oxygen. So I have to write the 14 H plus ions on the left hand side of that reaction. Understood? In the fourth step, we are writing the entire reaction and also we are balancing the oxygen because this is in an acidic medium, right? So we need to balance the oxygen by writing the water molecule. So there are 14 hydrogen are there, we need to write the 14 hydrogen. So 7 oxygen will be balanced. In the fifth step, add an electron in the respective sides of the half reaction to balance the charges. Thus, the oxidation and the reduction of the half reactions can be written as follows. We know that I can write here the iron from +2 state to the +3 state, it is changes. We know that the electron will be lost, only one electron will be lost. Is it right? From +2 to +3. Whereas Cr2O7 2- will be get reduced to Cr3+. So this is a +6 oxidation state, get reduced to +3 oxidation state. So there are 3 electrons will be involved. There are 1 electron and there are 3 electrons. We need to balance it now. So I will multiply it with a 3. Here you can understand that during this chemical reaction, there are 2 chromium atom will be there and the oxidation state will be changes from +6 state to +3 state. Is it right? So the electron will be lost by 3 electron. But there are 2 chromium atom will be there. So it has to be multiplied with the 2. So it has to be become 6. Why it has to be become 6? Because we know that 1 chromium atom loses 3 electron. But there are 2 chromium atoms are there. So it has to be multiplied with the 3, you will get 6. So multiplied both the sides with the 6, you will get, and here by 1, and you will get Cr2O7 2- plus 14H plus 6 electron and Cr3 plus 7 electron. And here the 6 electrons and the 6 electron will be lost. So that the final equation can be written as 6Fe3 plus give rise to 6Fe2 plus 6 electron. Why I have written this reaction? Because I am multiplying the entire reaction with the 6. So you will get this equation. So finally if you cancel the first and the second electrons which has been present as I shown you, you will get this final equation. 6Fe2 plus Cr2O7 2- which gives us to the 14H plus and gives us to the 6Fe3 plus 2 Cr3 plus and 7 water molecule. This is how, if it is given in the acidic medium, we need to balance the equation by ion electron method. Hope you all understood with this method. Now let us discuss with an example, then you will understand in a easy way. The permanganate 7 ion, that is MnO4- in a basic solution oxidizes the iodine ion O- to produce the molecular iodine and the manganese 4 oxide. Write the balanced ionic equation to represent its redox reaction. So here they can give the question like this also, balance the following redox reaction by half reaction method, but here they have given in a basic medium. Now let us solve this problem, then you will understand in a better way. So the first step is writing the balance equation or the skeleton of that equation. MnO4- plus I- give rise to MnO2 plus I2. Is it right? Now we need to understand which one is undergoing oxidation and which one is undergoing reduction. We don't know. Is it right? So I'll calculate the oxidation number for this MnO4. So now I will consider Mn as X. So X plus 4 into -2 is equal to -1. X is equal to 4 2s are 8. So 8 is equal to -1. X is equal to 7. X is equal to plus 7. Is it right? The oxidation state of the MnO4 is plus 7. We know that iodine from the 0 oxidation state to the 0. This is in a elemental form. So it is 0 and this is in a -1 form. And for MnO2 again, MnO2, I'll consider Mn as X. X plus 2 into -2 is equal to 2. X minus 4 is equal to 0. X is equal to plus 4. This is how we will calculate the oxidation number of this one. So it is plus 4. So from this you can easily understand that MnO4 will be get reduced to MnO2 by losing 3 electron. Is it right? So this is reduction, and I minus, that is iodine minus, will be get oxidizes to I2, where the oxidation will be taking place here. Why it is oxidation? Because oxidation number of the I will be changes from -1 to 0. It has been increased. So it is oxidation. This is the first step. You need to identify the oxidation and the reduction which is taking place in the entire redox reaction. And in the second step, step 2, we need to separate it out, that is oxidation half reaction and reduction half reaction. How to write this? Oxidation means I will give rise to the I2. Is it right? From -1 to 0 oxidation state. Whereas in the reduction, MnO4 minus give rise to MnO2. This one will be in the +7 oxidation state and this one will be in the +4 oxidation state. Is it right? This is how we need to split the reaction. In the third step, step 3, we need to identify that how many reactants are involved in a half of the oxidation and half of the reduction. We know that I minus give rise to I2. So there are 2 iodines are involved in this oxidation. So since on the left hand side there are only 1 iodines will be there, on the right hand side there are 2 iodines will be there. So we need to multiply it with the 2. This is how we need to balance the half of the oxidation and half of the reduction reaction. Now I'll take the reduction half reaction where MnO4 minus give rise to MnO2. We know that there are 4 oxygen will be there and here only 2 oxygen will be there. I'll write 2 water molecule. If I write 2 water molecule, it will become 2 oxygen, but here 4 oxygen will be there. So 2 plus 2 it is 4. But on this side, you know, while balancing the oxygen, we need to add 4 water molecule give rise to 2 water molecule plus 4 OH minus ion. Why is it like this? Because when we are dealing with the basic medium, please understand that while balancing the oxygen, you know, we need to add the OH minus ion on the right hand side of the reaction so that it will become a basic medium. Whereas in the acidic medium, while balancing the oxygen and hydrogen, we added the H plus ions on the left hand side. But here it is reversed. We need to add the OH minus ions to the right hand side. Now I can cancel 2 water molecules with the 2 water molecules and entire equation can be written as it is MnO4 minus plus 2I minus plus 2 water molecule give rise to MnO2 plus I2 plus 4 OH minus ion. This is how in the third step we need to balance the oxidation and the reduction reaction. Okay. In the fourth step, step 4, we know that in the iodine give rise to the iodine 2. Is it right? So, how many electrons are involved here? Only 1 electrons are involved. Is it right? So, I can write only 1 electrons will be involved. Whereas, MnO4 minus give rise to MnO2. How many electrons are involved here? By losing 2 electrons. Is it right? So it is 2 electrons are involved. Now we know that there are 2 electrons and 1 electrons will be there. So it has to be multiplied with a 2. I have written the oxidation and the reduction reaction. We know that in the oxidation, iron will loses 2 electron. Is it right? Yes. Whereas the manganese from 7 oxidation state to plus 4 oxidation state, it has been changed. So it will loses 3 electron. Now we know that the electrons are not one and the same. For my convenience, I will multiply it with the 3 and 2 in the entire equation. So I can write it as 2MnO4 minus plus 2I minus plus 2 water molecule, which give rise to 2MnO2, 6 iodine it is, plus it is 3I2 plus it will be 6 electron will be get cancel each other. Then it will be multiplied with the 8. 4 2s are 8 OH minus ion. This is how we need to balance the equation, learning about by understanding that how many electrons are lost or how many electrons will be gained during the oxidation and reduction reaction. Remember, this is a oxidation and this is a reduction where iron will loses 2 electron. So it is 2 electron, whereas MnO4 minus loses plus 7 oxidation state to plus 4, hence it is a reduction. So 3 electrons will be lost, hence I multiplied with the 3 electrons, with the 2 and 2 electrons with the 3. So I will get this final equation as like this. 6 hydrogen and 2 2s are 4. So 4 water molecule, because you are multiplying this equation with the water molecule. Already we know that water molecule and OH minus ions are already there. So I have written the water and the OH minus, which we are already added in the last step. Okay. This is how we will balance this equation in the basic medium by adding the electron. This is how we need to balance the equation. Hope you all understood with this method. In the next slide, we have applications of redox reaction. So this redox reaction which play a very important role in the chemistry, especially in the titration. So when you come to the second PUC, you will understand that the titration is more important. Even in your first PUC also you have done with the titration by using indicator. But in a second PUC, you will do the titration of redox reaction where one is getting oxidized, one is getting reduced by using self-indicator. So this play a very important role in the practicals. Okay. In the redox system, the titration method will be adopted to determine the strength of reducing agent and oxidizing agent using redox indicator. The use of indicator during the redox titration can be illustrated as follows, where the self indicators and the internal indicators can be used for this. So we all know that when in the first PUC as well as in the second PUC, we will do the titration where the oxidation and redox reaction will be taking place. When one which is getting oxidized, one which is getting reduced. In both of these reactions, redox reaction which is happening by using self-indicator and one is by using internal indicators also. Not only this redox reactions which is helpful in the titration, which is also helped in electrode process and the redox reaction. What is that electrode processes? Already we have learned that when a metal rod which has been dipped in a solution containing its own ion, equilibrium will be established between metal and a metal ion of the solution. Due to the equilibrium, the potential will be developed by the metal with respect to the solution. This is potential which is also known as single electrode potential or the half cell electrode potential. So in the electrochemistry also, in your second PUC, you will going to understand what is the electrode process by taking the two different electrode, one which is a metal, another maybe in the non-metals also. So in that entire electro processing, we will take the metal solution where oxidation and reductions which is simultaneously happening, especially at the anode, the electrode were getting oxidized and anions will be get attached to it, and it is connected to the positive terminals of the battery, and loss of weight in the electrolytic cell will be taking place. Whereas at anode, electrodes will be get reduced and cations will be get attached to it, and it will be connected to the negative terminals of the battery, and the gain of the weight gain of the electrolytic cell will be taking place. This is how, by using this electroprocessing also in the redox reaction, which play a very important role to develop the potential. Okay. So at the last, I like to say that this is a small unit in your first PUC. Try to work it out, and it is one of the easiest unit where you can easily earn 4 on 4 from this unit. And especially with the types of redox reaction and the balancing of redox reaction by using oxidation number method and by ion electron method, it is very important. Try to work it on with the acidic medium as well as in a basic medium. We'll meet you with the next session with a new chapter. Till that, take care and be safe. Thank you.